During an electrical panel inspection, several issues can indicate problems and potential hazards. Firstly, a missing panel cover is a significant safety concern. The panel cover is designed to protect individuals from accidental contact with live electrical components inside the panel. Without the cover, there's an increased risk of electric shock or electrocution if someone were to touch exposed wires or terminals. Secondly, the main breaker must be appropriately rated for the service amperage. The main breaker's purpose is to protect the entire electrical system from overcurrents. If the breaker's amperage rating is lower than the service amperage, it may trip frequently, causing nuisance outages. Conversely, if the breaker's amperage rating is higher than the service amperage, it may not provide adequate protection against overcurrents, potentially leading to overheating, damage to wiring, or even a fire. Thirdly, double-tap breakers are a common violation. A double-tap breaker occurs when two or more wires are connected to a single breaker terminal. This is generally prohibited because most breakers are designed to accommodate only one wire per terminal. Double tapping can lead to loose connections, overheating, and arcing, increasing the risk of electrical fires. Fourthly, wires must be properly secured within the electrical panel. Proper securement ensures that the wires are held firmly in place and cannot be easily pulled or dislodged. Unsecured wires can create strain on connections, leading to loose connections, overheating, and arcing. Additionally, unsecured wires may come into contact with sharp edges or other components within the panel, potentially damaging the insulation and creating a short circuit. Fifthly, an overloaded panel is a serious concern. An overloaded panel occurs when the total load in the panel exceeds its capacity. This can happen when too many circuits are added to the panel or when existing circuits are heavily loaded with appliances and devices. An overloaded panel can cause the main breaker to trip frequently, indicating that the panel is being pushed beyond its limits. Continued overloading can lead to overheating, damage to wiring, and an increased risk of electrical fires. Duct tape is not an approved method for covering unused breaker slots or any other part of an electrical panel. Duct tape is not an electrical-grade insulating material and is not designed to withstand the temperatures and conditions found within an electrical panel. Using duct tape can create a fire hazard and may also prevent proper ventilation within the panel. Approved methods for covering unused breaker slots include using blank filler plates or covers specifically designed for that purpose. These covers are made of non-conductive materials and provide a secure and professional-looking solution. Always consult with a qualified electrician for any electrical work or repairs. Electrical work can be dangerous and should only be performed by individuals with the necessary training and experience. Working with electricity can be hazardous, and improper installation or repair can lead to serious injury or death. A qualified electrician will be able to properly assess the situation, identify any potential hazards, and perform the necessary work to ensure the safety and reliability of the electrical system. The National Electrical Code, or NEC, provides comprehensive standards for electrical installations. These standards are designed to ensure the safety of people and property. It is important to be familiar with the NEC and to follow its guidelines when performing any electrical work. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Familiarizing yourself with the NEC can help you avoid common mistakes and ensure that your electrical work meets safety standards. For example, NEC Section 110.12 covers neat and workmanlike manner. Electrical work must be installed in a neat and workmanlike manner. This means that the installation should be free from defects, damage, and unnecessary clutter. Wires should be neatly organized and supported, and connections should be properly made and tightened. A neat and workmanlike installation not only looks better, but also improves the reliability and safety of the electrical system. NEC Section 312.5 addresses the space in enclosures. Electrical enclosures, such as panel boards and junction boxes, must have sufficient space for the proper installation and maintenance of wiring and equipment. Overcrowding can make it difficult to work on the system and can also lead to overheating. The NEC specifies minimum dimensions for enclosures based on the size and number of conductors and devices installed within them. NEC Section 314.17 covers outlet box fill calculations. Outlet boxes, which are used to house electrical connections, must not be overfilled with wires and devices. Overfilling can damage the wires and devices and can also make it difficult to make proper connections. The NEC provides specific rules for calculating the maximum number of conductors and devices that can be installed in an outlet box based on its size and volume. NEC Section 408.36 addresses overcurrent protection. Electrical panels must be protected by overcurrent devices, such as circuit breakers or fuses. These devices are designed to trip or blow when an overcurrent occurs, protecting the wiring and equipment from damage. The NEC specifies the required size and type of overcurrent protection for various circuits based on their ampacity and application. NEC Table 310.15b16 provides ampacity ratings for conductors. The ampacity of a conductor is the maximum amount of current it can carry safely without overheating. The NEC provides tables that list the ampacity ratings for various types of conductors based on their size, insulation type, and installation conditions. These tables are essential for selecting the appropriate size of conductors for different circuits. NEC Section 250.122 covers equipment grounding conductors. Equipment grounding conductors are used to provide a low impedance path for fault current to return to the source, tripping the overcurrent device and clearing the fault. The NEC specifies the required size of equipment grounding conductors based on the size of the circuit conductors. NEC Section 250.130 covers methods of grounding. Grounding is the process of connecting electrical equipment to the earth. Grounding helps to stabilize the voltage and provides a path for fault current to return to the source. The NEC specifies various methods of grounding, including using grounding electrodes such as ground rods or metal water pipes. NEC Article 100 provides definitions for electrical terms. The NEC includes a comprehensive glossary of electrical terms. Understanding these definitions is essential for interpreting the code and ensuring that electrical work is performed correctly. Some common terms include ampacity, overcurrent, grounding, and bonding. Bonding refers to the connection of metal parts to create a continuous electrical path. Bonding helps to reduce the risk of electric shock by ensuring that all metal parts are at the same potential. The NEC specifies bonding requirements for various types of equipment and installations. A qualified electrician will have the knowledge and experience to ensure that bonding is performed correctly.